Good morning. Welcome to the profile filters in recommendation system. This session is continuation of profiles and profile and expertise making in machine learning. In this session we are going to discuss the concept of filters, content-based filters and collaborative filters in machine learning. Content-based filters are those filters based on a description of the item and a profile of the user's preference. It is best suited to situations where there is known data on an item. The content-based filter engine compares the items that are already positively rated by the user with the items he didn't rate and looks for similarities. These filters used in book recommendation, product recommendation, music genre recommendation, etc. The content-based recommendation engine will only recommend articles related to these categories like books, products, music, etc. and may never recommend anything in other categories as the user never viewed. That is considered as one of the drawbacks of these content-based filters. To understand the concept of filters, I will give you a simple example. Suppose we are visiting Amazon and select a book, namely Harry Potter. And after purchasing this book, Amazon will give us a prompt to review that book. You will give some rating, 5 star, 3 star, 2 star, something like that. If your star rating is below 3, Amazon will ask why you are giving this low rating. You can give some suggestion or you can skip that step. Anyway, you are giving some type of rating of that book based on the content of the book. Now what the Amazon get from you? Amazon get rating based on the content. And every book that's stored in Amazon library will have some metadata. Metadata means those data that is related to the content, the type of stories, the author, and also the ISBN number, etc. all these data. Now what the Amazon will do is its recommendation system will collect those users which gives the same rating. It creates a neighborhood based on this rating. Now Amazon will give those books that are rated by those users which have the same metadata. That means the metadata matching with Harry Potter. So you may get many books related to the metadata similar to our Harry Potter book. That means you get a collection of references or collection of recommendations of books of similar type. The problem is that you got only a Harry Potter type books recommendation. You will never get a mathematics book or a storybook other than the science fiction like Harry Potter. That is one of the problem related to content-based recommendation system. Here the term filter is used because every time when we visit a site or give some rating or recommendation through online, it will create a profile based on our name or our ID. That is called a user profile. This user profile is available in the internet. Using these user profiles, the recommendation engines or recommendation system will work. That is the idea. So filtering is actually a computer-based operation, or in more general a rule-based or machine learning operation that skews out valid information from the user profile and it generates a recommendation seed. And based on this recommendation seed, we will get more recommendation related to book, music, movie, etc. So we are going to see the second type of filters, that is collaborative filters. As its name suggests, here filtering happens in collaboration. That means the user collaboration. These filters based on the assumption that people who agreed in the past will agree in the future, and that they will like similar kinds of items as they liked in the past. That is a basic assumption. It can learn to give better recommendations as more information about users is collected. So if it contains a neighborhood of more users, it will give better recommendation. Generates recommendations using only information about rating profiles for different users or items. A user gets recommendations for those items that user hasn't rated before but was positively rated by users in his or her neighborhood is the main point. It is similar to movie rating. Suppose we are rating a movie at 5 star, then it creates a profile of neighborhood and we are included in the neighborhood which have more than 5 or 4 rating scale. Then it looks through or scan through all the users and skews out their movie recommendation. Suppose I am a 5 rated category member and there is also another member and the same 5 rating. Then I will get recommendation of that movie that is rated by the other person. That is the advantage of using collaborative filters. That means it collects information of users having the same rating scale. Then it shares the recommendation or shares those information from other users to everyone. So we get different categories of recommendation. That is the idea. So similar taste, it try to collect user profiles having similar taste. If I give higher rating to a romantic movie, that means I have a romantic taste, and it find out another user which has the same taste because it gives a 5 rating for that romantic movie. Then I could see one film but the other person couldn't watch that film. But based on my rating and based on my taste, my movie that I have watched earlier, it also give us a recommendation to other person. So that is the idea of collaborative filters. There is also some other types of subdivision in collaborative filters like user based and also item based. Then what is the role of machine learning in recommendation system? So machine learning for designing recommender system. There are 4 main steps involved in developing machine learning algorithms. The first one is find similar users or item. How to find similar users and item? That is the main question. For that we can use machine learning. The purpose of machine learning algorithm here is to mathematically design some measures to find the similarity. An easier approach is define the correlation. If the correlation is high, that means their tastes are almost similar. If the correlation is very small, their tastes are asimilar. That is the idea. Then another one is distance measure, Euclidean distance. Suppose 2 persons are watching two different movies and give 2 different rating. We can represent this rating in a 2-dimensional, that is an xy plane. X represents movie 1 and Y represents movie 2, and the rating can be denoted in ordered pair. And different person give different rating, so we have different points in 2D. Then we can calculate the distance between these 2 points. If the distance is small, that means the movie rating are almost same. Only movie rating. These 2 movies are rated, and this distance is small. The rating of movie, that particular movies are same. Another one is comparing the users. So we can try to find the similarity between users. For that we are using the cosine distance. Once you take the cosine distance between 2 movie rating, it will assess the similarity of users taste. That is the idea. That is a mathematical approach. Now second step is to predict the ratings of the items that are not yet rated by the user. So this is actually a prediction. For this prediction we can use machine learning algorithm, Bayesian learning algorithm, or some other clustering algorithms, anything. We can classify people profile into different group. For that actually we are using some clustering or classification algorithm, nothing else. For that we will use some measures like similarity measures. For that I am using correlation function, or sometimes we will use the Euclidean distance or cosine distance, something like that. And the third step is to calculate the accuracy of in prediction. So suppose we are predict the rating of a particular item or a particular movie by a user using our machine learning algorithm. Next step is to predict to check the accuracy. For that we can use root mean square error or mean absolute error and such familiar tools in machine learning. Then the fourth step is model selection and updation. See, the users have different fields. In our machine language, it is simply features. We have to select different features, and based on these features we can develop different models, and therefore we have to decide which model is better and which model to be used. For that we have to apply some model selection method. Then we update it automatically. The automatic updation will happen. For that we use machine learning. That is the idea. The one thing is to remember, there are different features available in the user profile. So we have to decrease the dimension. So we have to apply dimensionality reduction. For that we can use PCA or our auto encoder. Auto encoder is another option, and also we can use TSNE. TSNE means the T distributed stochastic neighborhood estimation. It will help us to get the same distribution as the full feature space distribution, and so the error is minimum. So we can reduce the dimension of the particular data into smaller dimension with keeping the same distribution in terms of similarity. So TSNE is another option to, for this dimensionality reduction. All these are related to our machine learning algorithms. Basically, understand this one. We are trying to classify the user profiles into different classes based on their preferences or rating, and we do the same algorithms in machine learning. Nothing new, but we have to understand how to define the similarity. For that we can use the mathematical methods like distance, Euclidean distance or cosine distance or correlation, anything like that. Based on that models, we develop machine learning models. Then we finally select the correct model, and we update the model with the fine tuning, and also automatic updation will happen using an API, high level API. So this is the basic idea related to machine learning algorithms in our recommendation system. So recommendation system using Python. The first method is a correlation based recommender, and it is implemented in a colab notebook. You can visit this link to get the complete details and the code, running code that is available in internet. The second one is also a surprise library, that is a library by sklearn, and this library is a high level API that help us to develop recommendation system with the minimum coding, and it will make use of collaborative models with some more fine tuning options available in that particular library. And it is for a movie recommendation. The data is built in available in that surprise library. For a complete details and full code, visit this site, this tiny URL, and you can go through that particular code. Then you got more information and more insights related to the recommendation system. So this is all about the basics of recommendation system and different types of filtering of user profiles related to developing recommendation system. Thank you very much.